Okay, in this tutorial it relates to the first assignment, which is on topographic maps. Now I'm going to briefly introduce topographic maps, what they are, why we use them, and then how we use them, and it'll relate directly to the exercises that you should work through and then assess, if you like, in the first assignment, which is the online quiz. If you can do all of the exercises, then you'll have no problem with the quiz itself. Okay, so topographic maps, here they are. This is a typical topographic map. This one is of Albury. And if you look at any topographic map, what does it show? Why is it different to other maps? Well, topographic maps show all the features, or many of the features, that are on the landscape. Now, that can range from rivers and roads to built-up areas. It shows us the heights of the landscape. Why do we need topographic maps nowadays? Well, it's a good question to consider because we have access to a huge range of digital maps. And I still think it's useful to understand topographic maps, how they work and how to use them. The main reason is because those digital maps are based on topographic maps, and the processes and techniques used to make topographic maps then just feed into digital maps. And so having an understanding of how to use them means you can understand digital maps even more. But also, of course, that digital maps require a source of electricity and power, and there are times when you don't have that, or even a connection to the internet. Now, of course, times you may not have that. And so it's a good idea to know how to use topographic maps in any study of the environment. Okay, so that's why we have topographic maps. So one of the main differences with topographic maps compared to things like say a street map or a map you might find just on your car GPS is that it also shows elevation. Now, if you look closely at a map, you'll see little numbers on them. And they are often, those numbers relate to what's known as spot heights. So that's the elevation of that place on that map. And so if we have a look at this one here, this is One Tree Hill in Albury, and it's 471 metres. Okay, that's great. And you can find other spot heights on your maps. But the really useful thing with the topographic map is that it shows elevation across the entire map using what's known as contours. Now contours, this one here, this group of contours around here is a good one to concentrate on because it shows the contours along Eastern Hill. Now a contour line is just defined as a line that joins up places of equal elevation. That's all that contours do. And so by looking anywhere on the map, near where you're interested in, you find that line that's nearest to it, it'll tell you the approximate elevation. Now, how do you know the elevation on that contour line? Well, you'll notice, let's say we pick something around, here we are in East Lavington, that this range of contours here start at 190. There's 190 on that line, there's 200 on that line, and there's 210 on that line. So they relate to metres above sea level, so that you know that that's the elevation of that landscape around those places. Now, the difference between those lines varies depending on the map that you're using, and that's known as the contour interval. And this piece of information, as well as other pieces of information, you'll find in the legend. So if we just shift this map up a little bit so that you can see it. This information here is the legend. Now, as I said before, topographic maps show a range of features, and you can see here, this is built-up areas, these are roads, this is railways, here we have, what do we got here? Schools, police stations, hospitals. Then in the section here, we've got the symbols that relate to forests, timbered areas, shrubs, mangroves. Not a lot of mangroves are in Albury. Windbreaks, indeed. And it also has our contour lines. Now, that and other information, dams and wells and all sorts of things, you'll find that the symbols that are on the map are explained in this part of the legend here. If you look closely at the legend, you'll also see often, or you should see every time in a topographic map, the contour interval. And the contour interval on this map is 10 metres. So that just means that between each line there's a 10-metre difference. Now we'll look more closely in how you read contour intervals when we come along to do our cross-section, but that'll come later. All right, now the other thing that you need to look at on your topographic map is the scale. Really important to understand scale, and we'll do a bit of work on that. So the scale of this map is 1 to 25,000. So what does scale mean? Well, on this map, at a 1 to 25,000, that means that the size of this area here, which is essentially Albury on the map, in reality is 25,000 times larger. Okay, simple, that's all it means. The distance between two roads, is in reality 25,000 times larger. So to work out the actual size of something on a map, all you do is you take a ruler, and let's say I want to measure I want to find out actually how big the trotting track, the diameter of the trotting track in Albury is. Okay, so let's see, I'm going to measure it with my ruler, and it's 1.1 centimetres. Okay, then I'm going to take a piece of paper, and so the diameter of the trotting track, there we go, just make sure you can see that, on the map is 1.1 centimetres. The scale of the map is 1 as to 25,000. And so to work out the actual diameter of the trotting track in Albury, don't even know if it still exists. It's 1.1 centimetres times 25,000. Now it's really important to put down that unit that you use to measure the distance. Because a scale, also known as a representative fraction or a ratio, is dimensionless itself, all right? It's just 25,000 times whatever you used to measure your distance on the map. Okay, I could have used millimetres. If I did, I would have written 11 millimetres by 25,000. All right? Now, to work out the actual distance, all you do is you multiply 1.1 centimetres. Keep saying the unit. It's a good practice to have. Keep saying the unit. Don't just say, well, I'm going to multiply 1.1 by 25,000. Just say, I'm going to multiply 1.1 centimetres by 25,000. So it's 1.1 centimetres times 25,000, which equals 27,500 centimetres. You keep the unit, all right? Keep the unit. Now, 27,500 centimetres is not a really useful way to talk about the length of something, and so we normally talk about that in metres or in kilometres. And so if it's in metres, then we know that there are 100 centimetres in a metre. So we divide that by 100, there's a decimal place, 2 spaces. So we know that the width of the Albury trotting track is 275 metres. Okay, so that's scale. That's how you measure the distance between something or the length of something on a map using the scale. But of course, different maps have different scales. Now, underneath this map, I've got the 1 to 100,000 map of Albury. That one over there. And you can immediately see the difference. Whereas before, on the 1 to 25,000 map, the size of Albury was quite large on that map. On this map, it's quite small. And that's how we describe the differences in scale. 1 to 100,000 is a smaller scale map because things on the map are smaller. That's it. 1 to 25,000 is a large scale map because things on the map appear larger. Now, you'd be surprised, perhaps, at how many people don't know that. People who work with maps don't know that. They get all confused about things being large. There's lots of information on the map, so it's large scale. Like there's big distances, so it's large. The world is a large scale map because it covers the whole. No, it's the map of the globe is a small scale map. It's tiny because everything is tiny on the map. Okay, so that's the first thing to understand. If you just think of it like that, things on the map look large, like a town or a forest or something like that, actually look large, then that's a large scale map. If it looks small on the map compared to everything else, then it's a small scale map. Now there are other ways to remember that, using scale as a fraction, and the smaller the fraction, the smaller the scale, but people tend to get confused at that point. So if you just think about things look large, then it's a large scale map. Anyway, so how would you work out the length of something on a 1 to 100,000 map? Just the same way. You measure the distance using a ruler, write that down in centimetres if you've used centimetres, then multiply that out by 100,000 and then convert back to metres or kilometres or whatever it is that you want to talk about that length in, whatever unit. Okay, now that's all very well using a ruler if the distance you want to measure is between 2 points in a straight line. But that often isn't the case. Now, sometimes you want to measure the distance, say, along a road or along a river, and they're usually squiggly. Some roads aren't, but let's say a river. So, or walking track perhaps, or fire trail, or something like that, that you really want to know the distance. As the crow flies, well, that gives you some idea, but unless you're in a plane, you'll be on the ground and walking it or driving it. So how do you measure distances using a topographic map where the distances or the path is curved? Now, one fancy way you can use is using this thing called an epeisometer. And it's just a fancy thing you can get at map shops. And if I can do this, show you, as you have a look at it nice and closely, you can see that it has numbers. Just take my glasses off. And it goes 0 to 10 to 20 to 30 to 40 to 50 to 60. And each of in concentric circles, and each of those concentric circles relate to a different scale. So depending on the map that you're using, you'll use a different scale, and then you zero that out. So it's back on 0. I think that's on 0. And then there's a little wheel at the bottom there, and you just, let's say you wanted to measure this part of the river, and you would just move that along there while making sure the wheel's going around. And I know that I'm measuring 1 to 25,000, so that's the one in the middle, and it's reading at about 2 kilometres. So that's one way to measure a curved path, is using an epeisometer. Okay, now usually we don't have one of these. What we do often have, though, is a piece of string, and you can just do, you can easily measure, well, not easily, but with a bit of care, you can measure curved paths. Okay, I want to go from here, and so I place one end there, and move the string, feel free to fast forward this bit if you want, move the string around the path of the river. At this point you can sort of let that go because you know where it's starting from, and you can keep going around there, around that meander, and let's say we wanted to end about there. Now, it's going to be a bit rough and ready, but once you've got that length, then you can take your ruler, measure the length, and it's about 10.3 centimetres. So 10.3 centimetres on a 1 to 25,000 map, I'd multiply 10.3 by 25,000 to get the length of that stretch of the Murray River. Now, two things to note about the string. I didn't actually use a piece of string because who carries around a piece of string with themselves? But if you are using a topographic map and you're using it a lot and you're out in the field, you might be carrying something like a compass. Who carries a compass with them? Anyway, I just happen to have this handy because we're going to explain compasses in a minute, and so I used this instead of the piece of string. The other thing is you need to make sure it's not stretchy. Shoelaces are often quite good if you happen to not have a compass or a piece of string, as long as that's not an elasticized piece of string. Okay, hopefully that was fairly straightforward. All right. One of the other things that you'll find on a topographic map are a whole lot of pieces of information in addition to what's on the map itself. Now, in the legend, just going back to the legend for a moment, one of the really important things to look for is when the map was produced. Because these days, in fact, the government organisations that made these paper maps have now stopped making them, pretty much. They only make them to order and they're quite expensive. Whereas once upon a time there was a big program to try and map the entire country and produce these maps for people to use. Now, of course, we all use digital maps, so people aren't using these paper maps. But they're still really useful, particularly if you're out in the bush somewhere and you don't have wireless internet coverage. But also useful if you want to actually have a look at something in the past and see how it's changed. Let's say some sort of environmental change. That can be useful. So to know when the map was made, you need to look for its date. And in this 1 to 25,000 map, you'll see over here when the map was created. And so up here, it says it was created in 1977. So that's quite some time ago. It was reprinted in 1990, but they didn't change anything in those 13 years. All right, so this map of Albury is what Albury was like in 1977. And in fact, if you've ever been to the Albury campus of Charles Sturt Uni, it's not on this map.